Now, observe that what we dealt with is when y is log of x to base e. What if now we have the logarithm to a different base, which is not e, the natural, the Euler's number, which we call the Napierian logarithm? If this is not the case, what we do to differentiate such a function? For instance, if what I have is, observe that but if the base is not e, then what we do, we simply apply change of base. Then we change the base. I'm sure that anybody watching this video, except you are still at the high school, you would have come across the concept of change of base for log functions. So we change the base. So e.g., if what we have is that log y is equal to log of x to base a, then we change the base by change of base. We have that our y can be written in the form log. We change that base to include e, to base e, right? So this becomes log of x to base e multiplied by log of a to base e. So this is the rule to apply. We simply change this to base e, applying this formula for change of base. Now it becomes easy for us to handle because this now is a product of two functions that are differentiable with respect to x. Here what we have is a constant, is independent of x, and we know how to handle that. Here this is log x to base e, it depends on x. We know how to handle that also. And therefore the derivative of y in this case, applying product rule, becomes, we differentiate this, keeping this constant, and so we have 1 over x log of a to base e plus. We keep this constant and differentiate this, but this is a constant, so the derivative of the constant is 0. So this becomes log of x to base e multiplied by 0. And at the end of the day, what we have is 1 over x log of a to base e plus 0, plus 0. So I say plus 0. Just for completeness sake, I'm writing that. Otherwise, this is simply this log of a to base e. The derivative of y with respect to x in that case is simply something like this. We will take examples to appreciate both this change of base case and the case where we do not have to change base. Alright. So we let y be log to base e 5x plus 3. And the question is, find dy by dx. Here we're going to find the derivative of this function with respect to x by applying two things. We're going to apply the derivative of log functions, which you have learned immediately now. And then to be able to do that, we'll also use the chain rule. So we'll first set the ground well. And so you see how we're going to apply the two constants. So here, let us take u of x to be, or simply I write u to be 5x plus 3. Then the u with respect to x is simply 5. If u is this, that means that y alone is log to base e of u. So to differentiate u with y with respect to x, so dy with respect to x is nothing by the chain rule dy with respect to u multiplied by du with respect to x. To compute y with respect to u is simply to compute the derivative of log u to base e, which is nothing but 1 over u, following what we did this afternoon or in this video. So what we have here is nothing but 1 over u multiplied by du by dx is 5. And this is nothing but 5 divided by u. Who is u? Our u is 5x plus 3. So this is 5x plus 3 divided by, this is 5 divided by 5x plus 3. So what we have got is that the derivative of y with respect to x is simply 5 divided by 5x plus 3. That is the result. And so you can see how to apply the two concepts. Let us take y to be, so this is still another example. We take y to be log to base a of 7 times x. Here our a is positive, just like it is at the ab initio when I introduce y to be log of x to base a, where a is not e, and then we did the change of base. The requirement is that a has to be a positive number so that it makes sense to deal with the log to base a. Okay. Here we're going to, our goal is to find the derivative of y with respect to x. And so to get this done, we change the base. So to change the base, we can rewrite this as, we have y is log to base a of 7x. This is nothing but log to base e of 7x multiplied by log to base e of a. Alright. Now it is easy for us to handle. Here we apply the chain rule to get what we have. We differentiate the constant to get 0. Here this is product of two differentiable functions of x. So we apply the product rule, apply the chain rule here, and then we get the result out. For the first term, we want to get the derivative of log 7x to base e. Here we can write this as log of u to base e, where u of x is simply 7x. And that means that the derivative of u with respect to x is exactly 7. It's exactly 7. And so if we have that, therefore the derivative of, with respect to x, of 7x, of log of 7x to base e, this is exactly 1 over u, then 1 over u du by dx, which is 1 over u times 7. And this is nothing but 7 over, our u is who? 7x, and this is nothing but 1 over x. So when you differentiate log of 7x to base e, you end up getting 1 over x. Interesting results at that.